to Balvikan Bhate with your mentor Abhilash Sarkar. Now in this chapter, we will move on to the problem number 17 in matrices. So the 17th problem will start from can it be seen properly? 17. Too much light. So 17 problem starts from okay. So it says to find the product for A is given as 1, 3, 5. B a matrix given by 1, 3, 5, 2, 1, 3, and C is given as 1, 0, 2, 3, 1, 4. So we have to find AC and BC you have to find. So let's take AC first. So A is of matrix 1 cross 3 and this is 2 cross 3. So multiplication, whether it is possible, the number of column in the first, number of rows in the second are not same. So in this case the multiplication is not at all possible. Okay, so oh sorry, AC C is of 3 cross 2. Here it is possible because number of column in first A and number of rows in C is same, so we can go for it. So 1, 3, 5 and 1, 0, 2, 3, 1, 4. I need to say AB is not possible, AC is possible. Now we'll do. So what we'll do, 1 into 1, 1, 3 into 2, 6, 5 into 1, 5. This is the first item, and second will be, and now this is order of 1 into 3 and this is of order 3 into 2. So I will get order of 1 into 2. So second one is 0 plus 9 plus 20. So this is equal to 11 plus 1, 12, and this is 20. So this is of the order 1 into 2. AC is done. Now what else? BC. So BC for that 2 into 3, 3 into 2. This is also possible. So 1, 3, 5, 2, 1, 3, 1, 0, 2, 3, 1, 4. So 1 into 1, 1, 3 into 2, 6, 5 into 1, 5, 1 into 0, 0, 3 into 3, 9, 5 into 4, 20, plus 20, then 2 into 1, 2, 1 into 2, 2, 3 into 1, 3, 2 into 0, 0, plus 1 into 3, 3, plus 3 into 4, 12. So this is the case. So ultimately 1, 4, 12, 29, 7, 50. So this is the result after the multiplication. Moving to next. Next is your 18. Okay, so 18. It is saying expand and simplify where possible. Expand and simplify where possible. Okay, so thing is given a plus 2I whole square, and second one is given as a minus b whole square. Now this is matrices A, B, I you can know this is identity matrix, or it can be taken in any form, but it is generalized mathematics is given where A, B and I all are matrices of any order, that mean to say. So wherever possible, now if we work with the first one 2i whole square, so for the whole square we cannot write the formula, so rather we can keep one after another. So this is okay because we are multiplying the same thing keeping side by side. So now for multiplication and summation where both are things come, so this rule is associative. So associative means if I take the first one and I can multiply and the same without changing the orientation or order, we can multiply this. Okay, so now when we will multiply again further, this is again the associative, so a into a plus 2 into I into a. Okay, so now plus, then again 2 is also a scalar, so 2 can be acted like anything. So 2 into 2 4, because scalar we can multiply, there is no restriction for scalars, and this will be I into I, rather we can write I into I. So a into a will be definitely what we will get. We have seen for any matrices a into a is a square, we can write, because that follows the square. 2 into either you multiply identity matrix with other matrix in any orientation, keeping I first or I last, you will get always the same result as the matrix, because I will not change any, I will not deviate the value of the matrices in any way. Okay, so you can keep this as both same, and then I into I will get identity matrix. Okay, I into I will change, because if you see identity matrix is something like that. Now if we multiply the same matrix with, so if we multiply, now see the result, 1 into 1 1, 0 into 0 0, so that means 0, 1 into 0 0, 0 into 1, so 0, 0 into this 0, 0, this into this 0 into, so you will say, you will find I into I is what I am taking an order of 2 into 2 to further simpler calculation. You can go with any order, you will get the same identity matrix for when you will multiply two identity matrices together, or if you can multiply multiple identity matrix also, you will end up with a this as a result identity matrix. So this is the case, and now further if we reduce it, I square 2a to a, anyhow you can add the scalars, so 4a and ultimately 4i. This will be the ultimate result of this. Okay, so this is the first one. The second one is already we have seen, if it is a generalized form, then also the rule will be same. Square means we have to keep the same way, one after one. Okay, now as it is associative, this is also taken as minus, means plus of minus b you can take. So you can keep in the same order without changing the orientation. So this minus is a minus 1 scalar, so minus 1 scalar will come in the prior to the whole multiplication. You can keep it without changing. So this is a into a minus b into a minus a into b plus b square. Now this we cannot say the same, as I've seen earlier also. This could be possible, but this also cannot be possible, or all the variation is there. Even if it is possible to multiply, there may not be possible that both the values are same. Sometimes it may be same, sometimes it's not possible at all to do multiplication. So this we can also, though you have to keep it like that. So this is really a square plus b square, and something you have to write it like this. This is the simplest form of that. Okay. Okay. Next, we will move on to the problem number 19. Problem number 19 says if a square minus equal to, this is an equation given 2a plus 3i, find aq and a to the power 4 in the linear form of of AA plus LI, where A and L are scalars. Okay. Anything else? Nothing. Okay. So this is given as a task. Sorry. So what we'll do now, as you see, this is a square is given as this. Now you have to find a4. So a4, if you want to find, this is, we can write a square into a square. Okay, it's simple as this. So a square can be replaced with this as is given plus 3i, and this is 2a plus 3i. Now the same thing will follow. 2a plus 3i, first will break into 2, so this 2 can be kept at the initial position where it is a scalar. So this can be placed anywhere because this won't change, that whether you multiply with this 3 or multiply with this, the result ultimately after doing the all multiplication will get the same result. So this is 4 into a square, a into a. I am just not keeping a into a, straight away I am doing a square. So 2 into 3 6, this a into I into a. Okay, 2 into 2 4, a square, 2 into 3 6, I into a, then plus 6 a into I plus 9 I into I square, you can say. So this is 4a square will be same as it is, or further, because here you have to bring it in the same form, so a square can be replaced further with this 2a plus 3i again, and this will convert into 6a only, this also convert into 6a only, and this 9i square will convert into 9i. Now further we'll bring it here because we need in the form of, so this again will be, now we are finding a to the power 4, so 8a plus 12i, this 6 plus 6 12, a again, and 9i. Okay, so this is equal to 8a 20a plus 12 and 1 21i. So this is your k value here, this is your l value, so this is being represented in this form. Okay, so now we'll look into the next problem, that is problem number this is the next problem, because we have to find both aq and a4. So aq, if we want to find, so that can be also divided into this. aq is equal to a square into a, that will give you aq. Okay, definitely. So a square can be represented at 2a plus 3i into a. Now we will break into 2 a square plus 3ia. Now this also can be represented as 2a plus 3i plus 3a ultimately. Now this will turn into 4a plus 6i plus 3a. So this will become 7a plus 6i. So here this is your K, this is your L. So this also can be represented in the form. Okay. So this, I am not doing algebra. This is also true for matrix. You can take any order of A and try whether we can write it or not. A cube with A square into A. You find the result. So you can take any order 1, 2, 3, 4. If you want to check whether A cube can be written as. So first, what I am doing, A into A. So 1, 2, 3, 4. Let's see. A cube means what you are doing, A into A. So this is the left hand side, and here you are writing A square. So you have to find this, then after you multiply it with another A, whatever is the result there, then you find consecutive A into A first. The same thing you are doing here. There is no, so this can be written in matrices also, as we can write in algebra. Okay. So the next problem I will bring is number 20. Multiplication identity of a matrix. This is same as that I've seen. Okay. Now okay, now I will move to find transpose. Already seen, but again this as transpose you can find. Okay, so we'll see this problem. A is equal to given by, this time one element is given as a variable. So how that matrix will behave when we take in an equation or something to solve. How will you solve that? Okay, this is a basic one to solve variable. So I'll go with that, and where if the condition is that A is equal to B, the matrices are same, then find X and Y. So this is the simplest form of finding variable, but it is, you can say, the basic one, because this will, the same concept will be applicable where when we solve the equation of matrix with variables. Okay, so now A is equal to B, that means this is equal to this. If I keep the matrix set side by side, when the matrices are said to be same, then the one concept is that their respective elements of those matrices which are in same places are has to be same. So that means if I say 1 1, column 1, row 1, the position matrix, if it is the element is X, so there if I compare the matrix which are same, the position of that element has to be same. So X is straightforward, you can say the 7, and 7 was, now we are only looking after the X and Y, so we will not talk about where it is same. So this also has to be same with this. So Y you can say is equal to 5. So then only A is equal to B. Okay, this is the simplest concept, but this concept will be useful when we solve the matrix equation with variable. So we'll move on to 21. Let's see any further problem regarding this is there or not. Yes, it is said if matrix is given as X plus 3, 2y plus x, z minus 1, 4w minus 8 equal to minus x minus 1, 0, 3, 2w. So these two matrices are same, then find the value of what is given, matrix X plus Y. Find the value of matrix X plus Y, X plus Y plus Z plus W. Oh, this is so this you have to find. Now let's say if two matrices are same, so what we can write, the respective position elements are same. So x plus 3 is equal to minus x minus 1. So this is first equation. So there is no other variable, so we can solve the x. So 2x is equal to minus 4, x is equal to minus 2. So first value of this is found out. So 2y plus x is equal to 0. So x is already minus 2, you know. So y is equal to minus 1. So that you have found. And the second, z minus, this is also straightforward, z minus 1 is equal to 3. So z is equal to 4. And the last one, 4w minus 8 is equal to given 2w. So this is equal to 2w is equal to 8, and then w is equal to your 4. So all those values are known. Now if we put this value here, x is equal to minus 2, matrix minus 2, y is equal to minus 1, plus z is equal to, what is that, 4, and w is equal to also 4 is given. Okay, so this is minus 1, minus 2, yeah. Now when we will add matrices, the respective elements will be added. So 4 will be added to minus 2, so this will become 2, and 4 will added to minus 1, so this will become 3. So this will be your ultimate matrix, 2 and 3. This is the order of 1 cross 2. Okay, so this is the simplest problem. Okay, so now I'll end up here. In the next video, I'll start from number 22. So thank you for now.